So let's move straight over to Alessandro. It's great to have you on the show. I understand you've had a very busy start to the week. Now, the Uno is probably the best known Arduino board in the family. Why is it that you've decided to update it now?
Yeah, as you mentioned, it's been on the market for more than a decade. It was launched in 2010, and a couple of years ago, we celebrated 10 million of units sold. We released a limited edition, miniaturized version of the Uno. So over the years, we have been collecting a number of feature requests from makers, basically analyzing how makers start their journey in electronics. So what kind of tasks are more commonly done? What are the more complex tasks for beginners, and what are the limitations of a glorious microcontroller like the DDR that the Uno R3 has. So after researching for a while, because we have had this project actually on our table for quite a while, we finalized a design by creating this Uno R4 pair of boards, which includes so many things that we believe all makers were expecting.
Now, the Uno R4 is available in two variants. There's the Minima and the Wi-Fi. Can you just take us quickly through some of the key new features for each of those boards?
Sure. So the Uno R4 Minima is this one. It contains the RA4M1 microcontroller from Renesas, and basically that's it. So it's a very powerful, very affordable board to use all the features that are built in the microcontroller. It basically can do everything that the Uno R3 can do, but it is faster thanks to the new microcontroller, and it has even new features built in, like the DAC, which is able to provide analog functionality directly on the pins of the Arduino. It has a larger input voltage range because it supports up to 24 volts as an input voltage. It can work in HID device mode, so it can simulate a mouse or a keyboard. It has an op amp and a comparator, so a very powerful analog section. So all these things are available in this board. The Uno R4 Wi-Fi has all the things that I just mentioned for the Uno R4 Minima, and in addition, it has a long series of features, starting from Wi-Fi, of course, as the name says, Wi-Fi, Bluetooth, thanks to a coprocessor. There is an ESP32S3 coprocessor on the board, which basically adds more computing power, which is available to more advanced users. As you can see on the board, there is this matrix. It's a matrix of LEDs, 96 red dots, which are fully addressable and can be driven directly using a library and using a gallery of icons and animations that we are making available. And we are also providing a tool to create custom animations. So basically, it's a built-in, very simple, very, very straightforward display to provide feedback to users. In addition, there is a quick connector on the side to connect I2C devices, and much more. I'll stop here, but these are the main features of the two boards.
Of course, one of the key things people will be asking then is, what's the support look like in the Arduino IDE? Are these boards supported in there? And also, is that huge host of existing libraries compatible with this board?
Sure, they are supported on the Arduino IDE out of the box, so makers don't need to install any additional driver to use this board with the Arduino IDE. Just plug the USB cable. By the way, the USB is now a USB-C connector, and it will be recognized. We have working a lot on ensuring that the libraries are compatible also with the Uno R4, the official libraries that we maintain, and the third-party libraries of the entire Arduino ecosystem. So thanks to the collaboration of the library developers, we have been running this early access program with many of them to ensure that libraries are available. We are maintaining a web page which lists libraries that are still not fully compatible and need to be ported, with a list of alternatives and information about when they are going to be available. But most of them are working out of the box.
Now, 32-bit microcontrollers are new for Arduino products, and that's one of the sort of big changes here with the Uno R4. What was the appeal of the Renesas family of microcontrollers as the basis for this product?
Yeah, there are several values of the Renesas family that made it the ideal choice for this product, because we know that the Renesas microcontrollers are not that common in the maker market. So some people were surprised to hear about a new microcontroller, which in the end It's looking very interesting to most of them, according to the comments. Basically, it's a 5-volt microcontroller, so it allows us to preserve compatibility with the entire Arduino Uno ecosystem that exists, and is based on 5 volts. In addition, it's a very, very robust microcontroller. For such a board, which is a Swiss Army knife, basically, for all kinds of makers, and especially a very powerful learning tool for beginners and students, we need a robust microcontroller which can tolerate stressful conditions, wiring mistakes, all the kind of strange things that a beginner might expect from a board without burning the board or creating other damages. So in the end, in addition to a long list of built-in features of the microcontroller, because we are talking about a Cortex M4, but in addition we have a built-in DAC, a built-in CAN bus, the op amp. We have many things, so this made really it a good choice.
Now, as you mentioned, it's great for beginners. I think people who've moved from the Uno to some of the other boards in the Arduino family, they'll have been sort of hit by the fact that only 3.3 volts can be applied to some of the GPIOs. With this, you've retained the 5 volts, which is fantastic. Is there any sort of other overcurrent protection or anything like that in those IOs to make sure, you know, these are really robust for those makers taking their first steps with an Arduino?
Yeah, in the design there is a lot of hidden value, because we put a lot of extra attention in putting the diodes, protections everywhere to make sure that even the worst mistake from a maker will not fry the board or will not fry the USB port of the PC of users. Most inexpensive prototyping boards on the market, of course, do not have this kind of circuitry because it's an extra cost which adds up to the cost of the board. But for Arduino products, we believe these things are fundamental to make the product a product that is lasting forever, basically.
Now, when we're talking about errors people can make, and even professionals make mistakes sometimes, one of them is obviously the supply voltage that's supported on the board. So I think that's been increased. And also, my other question on that, is the USB interface also just limited to 5 volts, or is there sort of like power delivery support so you can use higher voltages on the USB interface?
No, there is no power delivery on this board, unlike we have on our other high-end boards that we released recently, like the Giga R1. In this case, the USB interface is 5 volts, but the input voltage that can be supplied from the power jack, the traditional power jack of the Uno, and also the V-in pin on the side of the board, supports up to 24 volts. This was very requested from makers because now it's very convenient to use a single power supply for projects that, in addition to the board, also need to power motors. So in this case, now it's possible to use a single power supply. Also, the thermal section of the board was really improved. So even when running at these voltages, the board keeps a very low thermal behavior.
One of the things you mentioned earlier in the new feature list that's on the board is the USB interface. We've got USB-C now, which means that that obviously opens up lots of new capabilities. And this particular board can also be used as a human interface device, a HID device. So, but one of the things that's nice about the Arduino, and the thing that's amazed me right from the day one with it, was the fact that the USB interface also allowed me to create sort of printf style text outputs to a terminal. So if I'm using that HID interface for my application, am I still able to output text messages to debug my code at the same time?
Yeah, sure. Because the USB is handled natively from the microcontroller, so both behaviors are supported. The more advanced users can fully use the USB interface without the limitation of the serial to USB bridge that was in the Arduino R3 design. In this case, there is full control over the interface. So as you mentioned, there is HID device support. The board can simulate to be a mouse or to be a keyboard, so it can basically be used to create any kind of gaming controllers for other kind of human-to-machine controllers. In addition, we even included another, since you mentioned debugging, I want to mention this thing. We added a feature that improves the way makers can debug their code. Actually, 2 ways. One is a built-in debug feature. So on the Uno R4 Minima, there is an SWD connector here on the board. You see it here. So you can plug this to a hardware debugging device, and connect that to the Arduino IDE, which now supports an interface for debugging. So you can stop the execution of a program running on the board, you can inspect the content of variables, and you can even change the content of variables while running. This is very powerful way to debug without putting too many print statements in your terminal. On the Uno R4 Wi-Fi, this feature is integrated in the main USB port, so you don't need an extra hardware debugger to do this.
So that's an interesting capability. Are you also providing some hardware debug tools, or is that something that people would have to source separately to do debugging on the Minima?
So no, on the Minima, the interface is compatible with all the commercial third-party debuggers on the market. So we recommend to pick one of them.
Yeah. One interesting feature of the Wi-Fi version of the board is the LED matrix. That's obviously something that makes it actually another way of sort of debugging code. You've got 96 LEDs there. That's a dream come true in many cases. What drove you to put the LED matrix on the Wi-Fi version, but not on the Minima?
That's a good question. I mean, one day maybe we should create sort of a movie with the backstage of all the design process behind these boards, because we ran through many ideas. Actually, we created so many designs, so many variants, prototypes that we could open a museum probably one day. So in the end, the temptation of saying, let's put also this feature on the Minima, let's put also this one. In the end, we decided to go for a very minimalistic board, the Minima, with the minimum set of features, like the name says, with a microcontroller, to have a very affordable product, and then have a more capable version, which is the Wi-Fi version, which also has the LED matrix.
Now, one of the challenges of any type of display is obviously turning your ideas into an image that you can then put into your code somehow in order to drive the display. Have you got any support for people who want to easily turn their icons or symbols into images that can be placed on that LED matrix?
Yeah, sure. The LED matrix is addressable with a very abstract library. So there is an Arduino style library with very simple commands that allow you to draw pictures, to change pictures, to refresh the LEDs. By the way, for the more advanced users who are following us, the design technique behind this LED matrix is called Charlie plexing. It's a very nice way to control a matrix without using too many pins, basically, because the LEDs are refreshed so fast that the human eye cannot see the refresh rate. At the same time, you can save pins, and we do not need any additional circuit or microcontroller on the board to drive the LEDs, which are driven directly from the microcontroller. This is a nice thing. We are providing a gallery of icons, a gallery of pre-made animations that users can call directly, and we are also providing an open source tool, a web-based tool to visually create icons by drawing on the dots, creating animations with the keyframes, and then exporting them as Arduino code with one click that can be brought into the Arduino sketch.
Now, there's obviously a lot of discussion around security when it comes to developing IoT applications. And with the Wi-Fi module there, obviously the Wi-Fi version of the board is going to be connected to the internet very quickly. I guess some people would be concerned about having where their SSID passwords, for example, and any other sort of security details for internet communication are stored in this system. Is there some sort of security aspect built in here as well?
Yeah, sure. So the Uno R4 Wi-Fi delegates networking to the ESP32 coprocessor, which has internal cryptographic features. So at the moment, at the time we're speaking, the Wi-Fi library will store the Wi-Fi credentials in the main microcontroller as usual. But we plan to release an update to this, which will seamlessly change the behavior to store everything in the ESP32 secure memory.
Now, obviously, with the Wi-Fi version, I think you've got Wi-Fi and Bluetooth available on that Espressif module that's soldered on there, and both of those are really complicated interfaces. There's a lot of software stacks that go with them, and then there's all the functionality that needs to be built on top. What are you doing within the Arduino development environment in order to make them simpler to use?
Yeah, sure. For the Wi-Fi, we are implementing the interface of the Wi-Fi library, the glorious Wi-Fi.h library that is now popular in basically all the Arduino compatible platforms. So the same examples, the same method calls that are available in tutorials, books, videos, projects out there are supported on the Uno R4 without the need to read a different documentation and set of comments. This is a very simple high-level API that basically allows to access all the Wi-Fi features and run a web server or a client or anything else. On Bluetooth, we provide the Arduino BLE library, which abstracts the main features of BLE, because we're talking about Bluetooth low energy. We have a roadmap of improvements in the future to also to expand the Arduino BLE library to the most recent versions of the BLE standard by adopting some more advanced features that are currently requested by users, but still very hard to use using the various commercial BLE libraries that are available out there.
We've covered a lot of ground on the two new boards, and unfortunately we're running out of time. So I'm just going to come in with one last question to you, Alessandro, so as we can also get a chance to talk to Robert and find out more about the Renesas microcontroller that drives all of this. I think one of the frustrations for new developers who are starting to get into the Arduino environment is that C compiler. The error messages are often very cryptic, and it's difficult to understand why the compiler won't convert my code into something that the microcontroller understands. Have you made any progress there in helping those who are new to programming?
Yeah, we introduced on the Uno R4 Wi-Fi a very new thing for Arduino, which is basically an error catching mechanism for fatal errors. So as viewers are people who are following this conversation know, when you make some programming mistake that can result in the board crashing, for instance, a division by 0 or a wrong memory access or something like that, a board will just become silent. It will crash and suddenly stop responding until you reboot it. So there is no hint to understand what the problem is and what kind of code is triggering the error. So we changed this behavior. Any fatal error now on the board will not make the board silent. The board will print a stack trace of the error in the serial monitor of the Arduino IDE. Always. So the board, before dying, will say, hey, I'm dying for this reason. And then there is a command that can be used to get even a more detailed explanation within the IDE of the error to find the line which was triggering the crash.
Super. That sounds like a major improvement. I remember learning C for the first time at university. The error messages that came up were not helpful in any way whatsoever. And my experience has been it's not really improved much in the last 20 years. So I think that's a huge improvement especially for the new people entering the makerspace. And yeah, congratulations on getting that feature in there along with everything else. Thanks ever so much, Alessandro.